Today what we're going to do is we're going to use the same table that we used in yesterday's notes. So we still have our basic functions, shifting right, left, up, and down. So again, it's just the same table just in case you need to refresh your memory. But today what we're going to do is we're going to use the transformations to write the equations. So let's scroll down to example 1. We want to write an equation from a graph. Given the graph below, give the equation for g of x. If we take a look at letter A, we have f of x is equal to x squared. So we have our basic quadratic function. And what we want to know is how are we going from f of x, the red graph, to g of x, which is the black graph. The easiest thing with your quadratics to do is to take a look at the vertex. And where is that vertex going? So this is the vertex of the red graph, and this is the vertex of our black graph. And so what we're doing is we are shifting it down 1, 2, 3, 4. So we have gone down 4. So if we've gone down 4, our function for g of x would be x squared minus 4. Remember, going down is going to be subtracting something away from our function. If we take a look at letter B, we have f of x equals 1 over 3 raised to the x. So we have 3 points on our f of x graph, 1, 2, 3, and we're looking at 3 points on our g of x graph. And it looks like these 3 points are going directly across from each other, and they're moving to the right by 2. And it works for all 3. So we can conclude that this graph is going to the right by 2. And since we're starting with this exponential function, right 2 is going to be inside that exponent with a subtraction sign. So we can say the g of x function is equal to 1/3 raised to the x minus 2. If you have any questions, let me know. Otherwise, you can move on to example 2.